So hello, today I'm going to introduce you guys about our product, which is Padlock. It's totally unbreakable and unstoppable. So on this product, we focus on material and process that balance durability, corrosion resistance, and cost effectiveness while eliminating unnecessary luxury features. For the base material, we use stainless steel grade 316. So the reason we use this because stainless steel is tough, rust-proof, and widely available, making it cost-effective for mass production. For the composition of this stainless steel, we put 65 to 70% of iron, 16 to 18% of chromium, 10% to 12% of nickel, and 2 to 3% of molybdenum. So the additional for the coating, we use zinc aluminum alloy coating. This is because this layer adds extra corrosion resistant and protects against harsh environment. That's all.
Hi, my name is Abdullah Hazim bin Abdul Manaf. Here I am going to present about fabrication process. First, we move to casting part. First of all, we will design mold creation. A prototype of the key is designed, often using CAD software. A mold is created based on this design. The mold has two halves that, when joined, form a cavity in the shape of the key. To let you guys know that mold can be made from materials like sand, ceramic, or steels, depending on precision and production volume. To make a superpower padlock key, we discussed and confirm that we will use sand mold for small scales or custom keys, and steel molds to use for mass production due to durability. Next, melting the metal. The stainless steel is placed in a furnace and being heated to its melting point, which is to 1370 degrees Celsius. Then we will need pouring the metal into the mold. The molten metal is poured into the pre-prepared mold cavity through a gating system. This system ensures smooth flow and minimizes air bubbles or defects. Next, let's go into cooling and solidification. The mold with the molten metal is allowed to cool, during which the metal solidifies into the shape of the key. Cooling time depends on the metal type and the mold material. After that, we will removing the casting. Once cool, the mold is opened to remove the cast key. In sand casting, the mold is broken to retrieve the key. In steel molds, the key is injected without damaging the mold. Next, we will going into trimming and cleaning part. The excess material, called flesh, from the casting process is removed using tools or machine. The key is also being cleaned to remove any residues like sand or oxides from the surface of the key. To gain more accuracy in our project today, we'll use precision machining. The cast key undergoes machining to achieve the exact dimension and tooth pattern required to fit the padlock. Our group will use a milling machine, which is it will shaping the groove and teeth of the key, and we will also use drilling machine, which is it will adding holes or slot in a padlock. Next, finishing part. The key is polished for smoothness and a shiny appearance. A coating such as we will use nickel or chrome may be applied for durability and corrosion resistance. Last but not least, quality control. Each key is being tested to ensure if it fits the intended padlock and operates smoothly. Any defective key are recycled and the metal is reused. So the next part is about cold work, rolling process for shackle manufacturing. First, cold work rolling. Cold work rolling is a process where the metal is sharp and strengthened without heating it above its crystallization temperature. Here's how it's applied to the shackle. Initial shaping of the rod. The straight steel rod is passed through rollers at room temperature to reduce its diameter and elongate it. This step ensures the metal has a uniform thickness and improves its surface finish. Next is work hardening during the rolling. As the metal is deformed, the grain structure of the steel is compressed and elongated. increasing its strength through wall hardening. Wall hardening makes the shaker more resistant to bending, cutting, and breaking. Next, we will bending the rod into the U shape. After rolling, the rod is being bent into the characteristic U shape of the circle using precision bending machines. The bending process involves press dies, which is the rod is clamped between dies that shape it into a U shape, and hydraulic or mechanical force. It was applied pressure to bend the rod without cracking or deforming it. Next, let's move to next step, which is surface finishing. The shackle is treated for corrosion resistance or durability. This includes painting using chrome, zinc, or nickel for a protective coating, polishing to smooth the surface and remove any imperfection from rolling or bending. Last but not least, quality testing. The finished shackle is being tested to ensure if it meets the required standard for strength, durability, and security. So I think that's all from me. Next, my friend will explain the next part of our project.
The production of grade 316 stainless steel involves multiple mechanisms, but today we will focus on three key ones: nucleation, diffusion, and heat treatment. So the first one, nucleation. Nucleation is the first step in solidification, where small particles form as metal cools. There are two types: homogeneous nucleation and heterogeneous nucleation. Homogeneous nucleation forms randomly and requires high supercooling, leading to large grains and weaker material. Heterogeneous nucleation forms on surface like mold walls, creating small grains which improve strength and corrosion resistance. For Titan lock, heterogeneous nucleation is preferred as it produces fine grains, making the padlock stronger and more durable. So for second part, diffusion. Diffusion is the movement of atoms within the material, ensuring even distribution of key elements. The three main types are interstitial diffusion, where small atoms like carbon move between larger atoms; substitutional diffusion, where chromium, nickel, and molybdenum swap position in the lattice; grain boundary diffusion, where atoms move along grain boundaries, speeding up the uniformity. In grade 316 stainless steel, chromium boosts corrosion resistance, nickel enhances strength, and molybdenum prevents pitting. Proper diffusion ensures a uniform structure, preventing weak spots. And for the last part, heat treatment. Heat treatment refines the steel's property. The key process here is annealing, where the metal is heated to 1040 to 1120 degrees Celsius, dissolving the carbides and making the structure uniform. After annealing, quenching rapidly cools the metal in water or air to prevent carbide precipitation, which can weaken corrosion resistance. We don't need normalizing or hardening because grade 316 stainless steel doesn't rely on heat treatment for strength. Its properties come from its alloy composition. Lastly, tempering at 200 to 400 degrees Celsius helps remove the internal stresses after machining or welding, ensuring dimensional stability or durability. In summary, the production of any high-quality material involves multiple mechanisms working together. Each step plays a critical role in shaping the strength, durability, and performance of the material. This is why a combination of process is essential to achieve the best results in manufacturing.
For our next part is aesthetic. The matte brushed stainless steel make it look premium and feels high-end. Its scratch-resistant finish ensures durability, maintaining the visual appeal over time. The rugged appearance make it look professional and strong. Other than that, we put ergonomic grip. The curved edge improve comfort, ensuring the product feels natural in hand. Texture groove provide better grip and functionality, enhancing practically during use.
Moving on to the next point in our presentation, which is the economic properties of our product Titan Lock. So, one of the few economic properties that we want to highlight to you is the durability. We believe that durability is one of the most crucial feature on a padlock. Our padlock is anti-corrosion, makes it resistant to wear and tear, including rust, and it also has the ability to withstand harsh weather, making it suitable for outdoor uses since it doesn't get rust easily. This also will further maintain its functionality and makes it usable for a long period of time. Since it doesn't break, you don't necessarily have to replace it. On to another point, which is security, and we also believe that it is a vital point in making our product relevant in the market. Since there is a lot of process involved in straightening our padlock is anti-theft, not easy to cut through, and it's very difficult to pry open. It is also can only be opened by using the keys provided. This would deter theft and vandalism. In terms of cost effectiveness, we use zinc aluminum alloy as the main component. We know that this material is cheap and affordable, making it easier to be mass-produced, and also not to forget that this component is very easy to cast. This would cut down the extra cost. And one of the composition that comes in mind is titanium. We know that titanium is widely known as in our industry right now because of its property. It is strong, anti-rust, and also very lightweight. But when compared to zinc aluminum alloy, it is also similar. However, titanium costs a lot more when we compare to zinc aluminum alloy. That's why we use zinc aluminum alloy as the main component. And lastly, the versatility. Our product comes in various sizes. Therefore, it can be used in a lot of situations. You can use it on a gate, bike, or even a safe. It is also has a lot of appealing design, which will, I believe, attract customers. One more thing, it is also sold at a reasonable price, and we believe that it can compete with the current market.
So, we are on the last part of our product, which is properties comparison. So here I want to explain about the properties comparison between the stainless steel and mild steel. As we all know, the stainless steel material is low maintenance compared to the mild steel that is actually high maintenance. This is because stainless steel is more durable and not easily damaged. At the same time, we don't need to buy the new product to replace the broken one. Now, we are moving to the next properties, which is hardness. Stainless steel is more hardness compared to the mild steel that is actually less hardness. Mild steel is more easier to be scratched or indented. Next, corrosion resistant. Stainless steel is higher corrosion resistant compared to the mild steel. This is because the amount of chromium in stainless steel is typically 18.5% compared to the mild steel, which is 1.5%. Chromium acts as the corrosion resistant of steel by forming a thin, protective layer of chromium oxide on the surface. This layer will prevent oxygen from reacting with the iron in the steel, which will cause to rust. Furthermore, the dislocation motion more complex on the stainless steel compared to the mild steel, which is the dislocation is more limited. Besides, the stainless steel is having the more strength than mild steel. This is because our product that consists of stainless steel material to withstand an applied force. compared to the mild steel that is more easily to be destroyed when the high force is applied. Finally, the dislocation motion. The stainless steel material can withstand sudden force, while the mild steel is not tough and will go plastic deformation over sudden impact.